We need to show that the minimum conductivity of a semiconductor sample happens when n is equal to ni times mu p over mu n. So we know conductivity is sigma is q n mu n plus q p mu p, and we also know law of mass action is ni square. So here instead of n naught I will just write n. That means the concentration of electron, and p is concentration of hole, of course. So this I will first write, because I have to show in terms of n, I have to find n, I will write a p in terms of n. So that will become q n mu n plus q n I square over n mu p. So that is my sigma in terms of n. Now in order to find minima value, I will differentiate it with respect to n and then equate to 0, of course. So this one becomes mu n and this one becomes q n I square over n square mu p, basically. So for minima or maxima, this will be equals to 0. So we will equate it to 0. As a result, it will be q mu n is equal to q n I square n square times mu p. So this goes away and this n becomes ni square, and then so n square becomes this one times mu n times mu p. So n becomes ni mu n times mu p. So that's the value. Now we need to see whether this is, when we plug in this value here, here, and we find the second derivative, we can tell whether it's a maxima or minima. So here there is a maxima or minima. So what I will do, instead of sigma over del n dn, so that would be q mu n, and here it is q n I square, and then n square becomes, of course, ni square mu n mu p, and I square mu n mu p times mu p. So this is becoming q like that. Of plug-in, I will just find the second derivative, what I wanted to do here. So this will be just n here. So this is the first derivative, which is this one, n square mu p, and I will find the second derivative and then I will plug in the value. So this will become 0 here, the first term, this is becoming 0, and this is becoming minus q and then 2, so that will become plus 2q ni square n cube mu p. So basically this is the only variable, and it becomes like that. So now when I plug in this value here and to the second derivative, I can see the result is positive because all these terms are positive. So as a result, we can say that this is a minima. So we know this value is a minima, which is sigma, this one, when n is equal to this one. So we will just plug in this value into the sigma value to get the minima sigma. So sigma is q n mu n plus q p mu p, and here we will just plug in the n value, which is ni square root mu p over mu n square root mu n times mu n plus q here ni square over n, and that n will be of course ni, and since this is in denominator it will be reverse q mu p times mu p. So this becomes q ni mu n times mu p plus q ni, the same thing, mu n times mu p. So the minimum value becomes 2qni, sorry, this is no more ni square, this will be just ni because ni square and the numerator and this ni. So yeah, this is becoming just mu n over mu p. So this is the q min value, sorry, q min value, sigma mean values, sorry, that's the minimum conductivity.